Well, here we'll find out intensity of electric field due to an uniformly charged circular arc. Okay. So here I consider a circular arc having radius A and line charge density is lambda. Okay. That is charge per unit length given in the arc, circular arc, is lambda. The center of the circular arc coincides with the origin of the Cartesian coordinate, and if we consider this y-axis is the reference line, so the terminals of the arc makes an angle theta 1 and theta 2. Okay. At the point P, we want to find out the intensity of electric field. So, as we know, the point where we want to find out the intensity of electric field, we have to imagine an unit positive charge. So here I consider a unit positive charge, and the force experienced by the unit positive charge is the intensity of electric field at this point. Clear? Now here I consider an elemental length, small elemental length dl, which can be also written as A into d theta. A is the radius and the terminals of the elemental length makes an angle d theta. So dl is equal to A d theta. Now intensity of electric field due to the charge in the elemental length at P is given by dE is equal to 1 by 4 pi epsilon naught dq by s square, distance square. Okay. Now dq can be written as lambda into A d theta. Lambda is the charge per unit length. So in the length dl, the amount of charge is given by lambda into dl, and dl also can be written as A d theta. So dq is equal to lambda into A d theta. Okay. So we get 1 by 4 pi epsilon naught. Here A cancels out. Lambda by A d theta. Okay. Now I resolute, and here is the direction of the intensity of electric field is that. Okay, this is positively charged, positive charge distribution. This one is positive, unit positive charge, so the direction should be like that. Okay, it is clear. Now I resolute this dE vector into two perpendicular components. This is dEx, this is dEy. As this one is theta, so this is also theta. So this becomes dE sin theta, and this becomes dE cos theta. Okay, here it is. Now one by one, I'll find out the intensity of electric field component along x-axis, along y-axis. Okay, so Ex, that is component of intensity of electric field along x-axis, that is integral of dEx, which is dE sin theta. The value of d is here, and look at the limit of the integration. Okay, it is minus theta 1 to plus theta 2. Why it is minus? Because with respect to this reference line, the direction of theta is here, theta 1 is here, and this is theta 2. So the limit should be minus theta 1 to theta 2. Clear? So this is minus theta 1 to theta 2. If we integrate, we will get negative of cosine theta. After putting the integration limit, okay, and simplifying, we will get 1 by 4 pi epsilon naught lambda by A cos theta 1 minus cos theta 2. Clear? Similarly, we can find out the intensity of electric field for y component. So here the integral of dEy, y component, if you put it and if you integrate, after simplifying you will get 1 by 4 pi epsilon naught lambda by a sine theta 2 minus plus sine theta 1. Clear? Now here from this result we can find out some intensity of electric field for some special cases. Okay, so first we consider intensity of electric field for semicircular ring. Okay, look at the diagram. Notice the diagram here. What should be the limit here for semicircular ring? This angle should be, that is with y axis, this theta 1 should be pi by 2, this theta 2 also should be pi by 2. Okay, and if we put the limit in the expression Ex and Ey, the component Ex vanishes. Clear? And Ey gives 1 by 4 pi epsilon naught lambda by a sine of pi by 2 plus sine of pi by 2, and we will get ultimately Ey is equal to, after simplifying, 1 by 4 pi epsilon naught 2 lambda by a. Is that clear? Now come to quarter circular ring. For quarter circular ring, just notice the figure. This theta 1 should be 0 here, and theta 2 should be pi by 2. It's very easy to understand. Now you just put the limit in the expression, what we have found out. What is the expression for x component? It is the Ex 1 by 4 pi epsilon naught lambda by a. In place of theta 1 I just put 0. In place of theta 2 I put lambda by 2. Simplifying, we get 1 by 4 pi epsilon naught lambda by a. Clear? Similarly, if we put the limit, value of the limit in the expression of y component, and after simplifying you will get this. Clear? So what is the resultant intensity? E is equal to square root of Ex square, Ey square, both having the same value. Okay, and what is the angle? Here look at the direction. Here it is Ex, this is Ey. Okay, so the resultant should be along this. Definitely it makes an angle phi is equal to 45 degree because Ex and Ey have the same value. Clear? Now once again I back to the semicircular ring here. The direction, about the direction. Here it is the Ey. Only the y component exists here. Is that clear? Only y component exists. So the direction of intensity of electric field for semicircular ring is directed along y axis. X component vanishes and having the magnitude here. Clear? Thank you.